Okay guys, let's take a look at today's lesson. So, rotation of conics. Before today, we were dealing with this equation, right? We would have a x squared and a y squared, x, y, and maybe a constant. So this is the equation that doesn't include this xy term. When we see the xy term here, that means that this is a rotated conic. Before today, all of our conics were either vertical or horizontal. I mean, there wasn't any option. It was either vertical or horizontal. But this term, this xy term, indicates that this conic has been rotated. Okay, so that's what we're going to be working with today. There's a whole variety of formulas that we need to be able to do this. And, well, let's just kind of jump in. So when we rotate the axes, let's kind of look at this picture right here. We're using a little x and a little y to represent our normal xy axes, the ones we've been using forever. And what we're using to represent the rotated axes are big X and big Y. Now, in a lot of textbooks, you will see this as like little x with a little, like a prime on it. I don't really like using that notation because when we square things and we have the little prime up there and we're squaring, it just kind of gets confusing. So on your paper, if you would just make sure that either it's definitely a little x or definitely a big X. I just think it makes our work easier to read with. So instead of doing the little x prime like a lot of textbooks do. So the big X is the rotated axis. And so this formulas, let's look at the formulas right here. So these formulas we're going to use to transform equations. And really, that's all I'm going to be doing with you today. That's all I have time to do with you today. It is possible to transform points as well. And to transform points, we would use these two equations. This is transforming points from little x to big X. That's what these equations do. And I'm not going to have opportunity to do an example of this, but we do have some on the daily work that you can practice. Okay, so that's what that is for. Sometimes we're kind of lucky and they tell us what angle measure we rotate through. You know, that's kind of nice. And sometimes we're not so lucky. And if it's the second case where we don't really know what angle measure that our conic is going to be rotated, we're going to use this formula right here. Phi, this Greek letter, phi, stands for the angle measure that we are rotating through. So if we do cotangent of 2 phi is a minus c over b, please note that a is the coefficient in front of the x squared, b is in front of xy, and c is in front of y squared. It's in that exact order. When we're looking at these in standard form or actually in general form, the x comes first. Just kind of think of it as you know, alpha order. The x squared comes first, then the xy, then the y squared. All right, and lastly, we will be able to tell what kind of, unless it's degenerate, we will be able to tell what kind of conic it is with these little formulas right here. B squared minus 4ac, you probably recognize that as the discriminant. B being the number in front of the xy, b squared minus 4 times a times c. That'll tell us, you know, if it's equal to 0, it's a parabola. If it's less than 0 or negative, it's an ellipse or circle. And greater than 0, it's a hyperbola. So that's kind of just the structure and the overview of what we're doing today. Are there any questions on that? All right, let's jump into the examples. Okay, so we're going to ease into it with number 1. Number 1 is actually very kind to us. The equation is very small, just xy equals 2. And we are asked to turn this, because this is a rotated conic. We can tell because it's got an xy term. This is a rotated conic, a little baby one. We're going to turn that into big X, big Y coordinates, and they tell us the angle measure we're rotating through. We're going to rotate through 45 degrees. So we basically are given pretty much all the information. What we're going to need to do is to use the formulas to write the equations to transform into big X, big Y. Those were those first two formulas on that last page that I circled for you. Those are the ones that we're going to be using. So we have little x equals, then we have big X cosine of 45 degrees minus big Y sine of 45 degrees. So this is the equation that we're going to use to substitute in for all little x's that we find. So let's clean this up. We'll use the unit circle values. We'll find that. So that's going to be root 2 over 2 big X minus root 2 over 2 big Y. That's what little x equals. Okay, now let's work on little y. So little y is going to be big X sine 45 degrees plus big Y cosine 45 degrees. Okay, so let's clean that up. Let's go ahead and take the unit circle values. So that gives us root 2 over 2 big X plus root 2 over 2 big Y. I'm going to pause here for just a moment. Are we okay? We have the formulas. So I'm going to take this. We're going to kind of focus on this equation now. We're going to take this little x formula and we're going to replace this little x with this. So we're going to have root 2 over 2 big X minus root 2 over 2 big Y. That we're replacing the x with. Now we're going to take the other formula, the little y formula, and we're going to put it in place of the little y. So root 2 over 2 big X plus root 2 over 2 big Y, and that equals 2. So let's pause here for just a second. So I found my formulas. I'm substituting them into the original equation that's a transformed conic. Or it's a it's going to be rotated. It's a rotated conic. So now it's algebra. We need to FOIL and combine like terms, that kind of thing. We're really in luck here in more ways than one. Notice how these are conjugates of each other. So that's kind of nice. You know, the outside inside terms are going to go away. So really we're just left with root 2 over 2 times root 2 over 2 is 2/4 or 1/2 big X squared. Outside inside, they cancel out, they go away. Minus root 2 over 2 times root 2 over 2 is 2 over 4, which is 1/2 y squared equals 2. Now that looks more familiar, more normal. We can see this is going to be a hyperbola. Let's put it in proper form. We would need it to equal 1. So I'm going to multiply through by 1/2, and that would give me x squared over 4 minus x squared, minus y squared over 4 is going to be 1. Now, it doesn't ask us to graph it, but I would like to graph this one just because to kind of demonstrate how to graph a rotated conic. So this is a hyperbola. Okay, I'm going to draw my normal xy. So this is the little x, little y. And my rotated axes are rotated 45 degrees. It's always an acute angle, and we always rotate from the x-axis. So we would rotate up 45 degrees to place our big X, big Y axes. That's going to be exactly in the middle, isn't it? So let's go ahead and write in. So this is big X, and that's big Y. Now what I do when I'm working with these is I actually turn my paper because I really have kind of a hard time tilting my head sideways and graphing. So I just turn my paper. I really can't turn the Promethean board, can I? So we're just going to kind of go with me. We're just going to kind of graph it. So this is hyperbola, and we know the center would be at 0, 0, and we would go 2 spaces either way to draw our little rectangle. And we know that it's the x is bigger, so it's going to go along the x-axis, so it's going to look like this. And that's my rotated conic. Now I want to show you something kind of interesting about this particular one. Now they're not all like this, but this particular one. If I go up here and I solve this for y, what kind of a equation is this? This is a rational equation, right? And the rational equation, look at how the rational equation looks. Isn't that cool? It is so cool. Okay, that's unusual and strange. We're not going to get to do that very often, but hey, I wanted to point it out on the type that we did. See how this, we're not going to be able to solve for y hardly ever, only in one like this. Not all, well, we'd have to get there. Maybe. So, are we okay with this? All right, so that's kind of fun. That is fun. Let's move to one, number 2. Maybe this will comfort you, or maybe it won't. Number 2 is like the hardest one that you would ever find, right? I'm doing like an easy one, and I'm doing like a really hard one. Just so that you know, once we get into it, this is like having to do every little step. So I want you to look at number 2 and notice that, well, we don't know what the angle measure is that we're rotating through. We have no idea. So let's just start with part A. Let's just start easy. We're going to use the discriminant to identify. So it's b squared, so 96 squared minus 4 times A times C. And we would multiply all that together and subtract, and we actually get 0. So this is going to be a parabola. Okay, so we just use that formula on the other page to determine what we'll end up with. This is going to be a parabola, which seems very strange to us, because if we would look at this, we would think this is going to be an ellipse, right? Because it's got an x squared and a y squared, but that is not how it's going to turn out. So it's kind of helpful for us to know what it's going to turn out to before we start working with it. Okay. So now it says use a rotation of axes to eliminate the xy term. Okay. So here's where we don't know. We don't know what the angle measure is, so we're going to have to look for it. So we're going to have to use our little formula. Cotangent to phi equals a over c. So a minus c. So 64 minus 36 over 96. Okay, that's my formula. And that's going to be 7/24. Now, the reason this one is the most difficult one is because typically we would end up with a unit circle value there, and we can just go along our happy way, right? A unit circle value for cotangent like root 3 or 1 over root 3 or something like that. Well, that's not what we ended up with. We ended up with a number, which means that we have to do more, because even if we had a calculator, that would not be helpful to use a decimal here. You can imagine multiplying through with decimals here would be a nightmare. So let me show you what we have to do. So we've got to go back to a formula that you've had access to. You just had no reason to use it for something like this in the past. Let's look at what we're really going to need is we're going to need cosine of 2 phi. So before I jump into why the formula we're going to use, let's just find what cosine of 2 phi is going to be. So if I draw my triangle, and that's 2 phi, and so that's cotangent, so what it's adjacent over opposite. So this is a special right triangle, a 7/24/25. So really what I want to be using, I want to be using cosine of 2 phi. That's what I want to be using. Okay, so this is what you would do every single time. Every single time that you had a problem like this, you would want to use cosine. And so we just read cosine off of here. You know, it's adjacent over hypotenuse, so 7/25. This is what we're going to use to find our angle measure. Okay, so now let me go back to the formula that you've had access to. You just had no reason to use it like this before. We know that the double angle for cosine is cosine squared minus sine squared. Also, you know, if we were to transform it, it'd be 2 cosine squared minus 1. We'll just keep using phi minus 1. We know that. We know that I could solve for cosine squared. So I'm going to. I could move the 1 over and divide by 2. Right? I could do that. Right? I could add 1 over, then divide by 2. I could square root both sides. Right? We could square root both sides. And we're going to get cosine is the square root of cosine 2 phi plus 1 over 2. I know what cosine 2 phi is. It's 7/25. So cosine phi is going to be the square root of 7/25 plus 1 over 2. Now, I would add those 7/25 plus 1, divide by 2, get it, use arithmetic, and that's going to turn into square root of 16/25. So cosine phi is the square root of 16/25, which means that cosine phi is 4/5. So everywhere I see in my formula cosine, angle, measure phi, I'm going to put 4/5. Now I could do the same thing for sine 2 theta, but why when I can just figure out, if this is phi and we know cosine is adjacent over hypotenuse, then I know that sine phi is 3/5. Okay, so that's before we ever even start the problem, right? That's why I'm saying this is like the hardest problem that you could do. All right, so those are what we're going to use in our formulas. So we're going to have, let's write our formulas over here, little x equals, we'd have 4/5 big X minus 3/5 big Y. I'm just using my formula from the previous page, just like I did over here. I'm just copying cosine right here. Cosine phi is 4/5, sine is 3/5. Little y is 3/5 big X plus 4/5 big Y. So I'm going to pause here for a second. Those are my formulas that I'm going to use. Does everyone see why we had to get the 3/5 and the 4/5 so we could fill out the formulas? Okay. So having a calculator and finding the actual angle measure is not going to help us with this problem. In this instance, it'll help us later, but not now. I mean, we need just a number, right? Okay, so what do you think we're going to have to do with those? What did we do with those over here? We had to substitute them in. We have to substitute them into this. You see, this is algebra intensive. Algebra intensive. And I said this is like the hardest one you're ever going to do, is this one. So we're going to get through this one. The other ones are going to seem like, that's just a cakewalk. I know how to do this. All right, so I'm actually going to need room. I need to erase this. Okay, we need a lot of space, a lot of horizontal space. So let me erase that part. I think you see where we're going, right? We're all excellent mathematicians in here. We can see what's going to happen. Okay. And some of us are thinking, yes! And some of us are thinking, oh my gosh, are you serious? Yes, I am. So we're going to start. We got 64 times. And then it's going to be x squared, right? X is this, 4/5 x. So 4/5 x minus 3/5 y squared. Okay, plus 96 times. It's xy, so x is 4/5 x minus 3/5 y times y, which is 3/5 x plus 4/5 y. Okay, so I've gotten this done. These two have been subbed into. Plus 36 times. I need my y squared, so y would be 3/5 x plus 4/5 y squared minus 15 times x, which is 4/5 x minus 3/5 y, plus 20 times y, which is 3/5 x plus 4/5 y, minus 25 equals 0. So I'm going to wait for a second while you copy that down, and I'm going to check all of my numbers and make sure my numbers are written correctly. So I'll give you a second. Someone was mentioning earlier, wow, wouldn't it be great if we just had this one problem to do on a test? I was thinking, oh no, maybe not, maybe not. Okay, that sounds fun though. I mean, it really does. So I have it copied correctly. So now what we're going to do is, yes, you have guessed it, we're going to start our foiling. Okay, so here we go. 64 times. Now, I encourage you to not simplify as you go. Leave it in 25ths. Otherwise, it's just going to be even more difficult than it already is. So I'm going to, instead of taking you through piece by piece, I know you know how to foil. I'm just going to talk through to you and tell you what I got when I foiled. Okay? So we did 64 times. It's going to be 16/25 x squared minus 24/25 xy plus 9/25 y squared plus 96 times 12/25 x squared plus 16/25 xy minus 9/25 xy minus 12/25 y squared plus 36 times 9/25 x squared plus 24/25 xy plus 16/25 y squared minus 12x plus 9y plus 12x plus 16y minus 25 equals 0. Okay, so you check your numbers. I'm going to check my numbers. Let's make sure we have it all correct. Okay, we're good. So notice that over here, yay, woo, negative 12x plus 12x go away. That's a little thing we can take care of. Very small. That's okay. It's okay. So now we're going to multiply out the 64 and such. So when you're working one of these, you certainly can have a calculator by your side. I don't want you to have to multiply 64 times 16 in your head. I mean, that's just not. So you could use a calculator for just the number crunching portion. So let's do that. So I'm going to multiply through by 64, and I'm going to get 1024 25ths x squared minus 1536 25ths xy plus 576 25ths y squared. Now let's work on the 96. So plus 1152 25ths x squared plus 672/25 xy minus 1152/25 y squared plus, let's work on the 36, 324/25, 324/25 x squared plus 864/25 xy plus 576/25 y squared, and then we have plus 25y minus 25 equals 0. Now let me check my numbers. You check yours. Let's see how we're doing. Yeah, actually they're all in 25ths, which is why I'm encouraging you to leave them in 25ths, because they're going to be much easier to combine like terms if they all have the same denominator than if they didn't. So, yep, we're looking good. So the good thing about, okay, you're like, good thing? What are you talking about? Okay, the good thing about this is if your xy terms don't go away, you've done something wrong. Okay, they have to disappear. They have to go away. And if they don't, there's something wrong. So I work on the xy terms first, just to see, oh, did I make a mistake somewhere? So let's look at the xy terms. So we have an xy term here, and here, and here. And if I add those all together, they do go away. Yay! Right? Yay! Okay. So I'm not going to do each one just for time's sake. I'm going to tell you what, and when you combine like terms, this is what you're going to get. 2500/25 x squared plus 25y minus 25 equals 0. Wow. That's what you get. That's definitely a parabola. Our little course, the discriminant was correct. And instead of taking the time to take you through putting that into proper form, I'm just going to, we know how to do that. We've been doing that for several days. Just go to proper form for a parabola, which would give me y minus 1 equals negative 4x squared. So that is our rotated conic. Now, we're going to need to sketch the graph here. I do need to know the angle that we rotate through just to get a pretty good, graph. The angle, that's really the only thing I need my calculator for. I would do arc cosine of 4/5, and I get about 37 degrees. Okay? So I'm going to rotate these axes about 35 degrees. We know that the center would be 45, so I need to go a little less than the center. So maybe somewhere like that. This is rotated 37 degrees, and this is phi. So let's do our other axis. So that's big X and that's big Y, and little x and little y. Okay. So this is a parabola. Its vertex is what, 0, 1? So its vertex would be right here. P, and we all know how to do this. I'm just telling you what I got, was negative 1/16. So this is a really narrow little guy. So it kind of goes like that. And there's our rotated conic. All right.